Hello, this is the second installment of the Ouch series by Oripy. We have tents as our hybrid variant today, tents with Sudoku. So yeah, looks a little bit more. We have a bit more visuals here in this variant. So let's take a look at tents. Alright, hold on, I gotta show you the rules first. So the rules of tent are, they're right here. Every tent must be paired up with an orthogonally adjacent tree. So you have some trees in the grid. Each tree must have a tent beside it, as you can see here. Tents cannot be horizontally, vertically, or diagonally adjacent. So, for example, this is not right because tents are touching. And numbers around the grid, like those, indicate how many tents in that row or column. So, for example, in our solution here, this column has 0 tents. This column has 2 tents. I hope you can see that. Yeah, you can. Yeah, so basically pair up a tent with a tree. Tents cannot touch other tents, and numbers indicate number of tents in their row or column. Right, so with that, let us just begin solving this one first. We can start with 0 because 0 cannot have any tents beside them, and this tree now helps because the tree for this tent must be here, and we can draw a line to connect the two, so we know that this tent must be for this tree. I'm pretty sure every tree must have a tent, right? Yeah, every tree must have a tent. This is wrong. And every tent has exactly one tree, and every tree has exactly one tent. So you have to pair them up exactly, meaning that this one still doesn't have a tent, and it can't take the tent on top because it cannot share tents. So the tent for this tree must be down here. And we can actually place empty cells around the trees because there can't be around the tents because there can't be tents touching each other. Okay, what else do we have? This tent maybe? I mean, we have a lot of tents here that are bordering multiple empty cells. Those tents do have only only 2 choices for where you can put the tents. I'm confusing the word tent and tree. My goodness. I hope you understand what I mean though. Alright, maybe we look at this 2 here. Oh, you can click on the... Whoa, I didn't know you could do that. But this 2 clue basically means that there are 2 tents in here, in these 4 cells, because we know the rest are empty. What does that mean? Well, I'm not sure, but what can we do here? All of these can have tents in them because they could have they are touching trees. Not sure though. Can I draw? No, okay. I can't do any other pencil marks besides the 3 things that I've already drawn. Fair enough. Okay. Because tents cannot touch, I can say that one of these 2 cells are a tent, one of those 2 cells are tents, and one of those 2 cells are tents. Yeah. What does that mean? Well, this cannot be a tent then. Because if it was, then none of those would be tents, and then you wouldn't be able to fill this column with 2 of them. So this cannot be a tent, which means now that this tree must have a tent here or there, and therefore that will complete this row. So none of those are tents. This tree cannot be completed, so those are not tents. Now this tree can be completed. This one? Yeah, this now can't be a tent because if it was, then none of those are 10s, which breaks this tree. So this can't be a 10th, which means that for this 2, you must have 1 10th in those cells, and this must also be a 10th, which is next to this tree. This tree can be completed with a 10th here, and we can mark all of those as empty. Sorry. We can actually, okay. This tree can now be complete with a 10th over there. That is not a 10th, therefore this tree needs a 10th over here. Cool. For this tree and that tree, yeah, they each need a 10th, right? And so, because this needs a 10th here or there, and this needs a 10th here or there, we can say that they need separate 10ths. So they cannot share a 10th here. If this is a 10th, then both of those are not 10ths. And then this 10th has to be shared by each tree, which isn't possible. So this can't be a 10th. The 10th for each tree must be on the other side. And then we can mark those as empty. This 10th cannot be completed. This one has to be a 10th for this tree. This one has to have a 10th over there. And the last one is over here. Complete. Nice. Okay. Sweet. Interesting variant. Interesting puzzle. Yeah. All right. So let's look at the 4x4, which is gonna show up right now. Yeah. There you go. Huge wall of text as the rules here. I'm gonna go over to the other scene where I actually have everything set up. Ta-da! Okay. Yeah, this is called Campground by Oripy, where we are combining the tense rules with regular Sudoku. So, let's look at the rules. Normal 4x4 Sudoku rules apply, so place the digits 1 to 4 in every row, every column, and every 2x2 box. This is now not tenths anymore, we're calling this camping. So, trees represented by the digit 1. Oh, did I say 4? Uh-oh, the rules say 4, I'm sorry. Let's quickly change that. So the rules say 4. In the actual page itself, it's actually not 4, it's 1. So I should change that immediately. They are 4. I think there's only 2 changes that you need though. Only those 2 4s have to be changed. Yep. Alright, we got it. Alright. So trees in this puzzle are represented by the 1. In the 9x9, they're represented by 9. But in this puzzle, they're represented by a 1. Trees are represented by digit 1, have to be determined by the solver. So I need to determine where the 1s are, which is normal for regular Sudoku as well. These are trees. A clue given outside the grid represents the sum of the 10th cells in its row or column. So each tree will be paired with a 10th, like regular 10ths. So if this was a tree, for example, let's make it green for tree. We need a 10th, let's make it orange for 10th, I guess. Because are these orange? They're also green, but I think most 10ths are orange. Basically, if you had 10ths that look like this, for example, then those digits would have to sum to that number over there, which is a 6. So those digits sum to 6. They could be 2 and 4. Like so. 10s may not touch one another, not even diagonally. So yeah, you can't have, you know, those two be 10s basically. And finally, the lake rule. Some cells surrounded by dotted lines are lakes. 10s and trees cannot be in a lake cell. So this cannot be a 10th or a tree, it is just a lake. And digits may not repeat in a lake. Well, they obviously cannot here, but in the 9x9 they can't repeat. Digits in a lake sum to the value in the top left if given. So lakes are basically killer clues, where whatever digit is here has to sum to the number in the corner. So this digit has to sum to 3, I guess. Yeah, so those are the rules. A lot of rules. But interesting way of mashing them together. Let's begin solving this one. We can very easily start with this 3 over here, which has to just be 3. Hey, wow. Instant 3 in the corner. Awesome. Okay. Now, right. The 6 and the 5 indicate that there must be at least 2 tenths in the row or column, because you can't have one digit sum to 6 or 5 in a 4x4. But there cannot be more than 2, right? There cannot be more than 2 because how would you fit 3 tenths in here if they can't touch each other? Even if you had them as far apart as possible, you cannot squeeze a third tenth in the middle. So yeah, the maximum of number of tenths in each row or column is also 2, meaning that each row and column marked here have exactly 2 tenths. Great. Every tree has to have a tenth, right? It's basically the same. Yeah, every tree has a tenth, every tenth has a tree. Well, we know ones are trees, so they cannot be a tenth. And therefore, the 5 here has to be made of 2 and 3. Right, because the only way to make 5 in 2 cells is either 1, 4 or 2, 3, but since you can't use 1, you have to use 2 and 3. We know 3 is in those cells, therefore 2 cannot be next to it. 2 has to be in one of those cells, which means 2 is in one of those cells now. Cool. 6 is also similar in that since you can't use 1, 5 because, 6 in 2 cells has to just be 2, 4. I forget that because it's the 4x4. 6 in 2 cells just has to be 2 and 4. There's no other way of making it. So what does that mean? No idea, but what else can we say about this grid in general? Since there are 4 trees, there must be 4 tenths, right? Yeah. Since there are 4 trees, there must be 4 tenths. Oh, and each tree, or each box here, has 1 tenth exactly, because you can't fit 2 tenths into the same box. Right? Otherwise, they would have to touch each other diagonally or orthogonally. So every box has 1 tree, making out 4 trees in total. Therefore, because we know there's 1 tree in those cells and 1 tree in those cells, 1 tenth in those cells and 1 tenth in those cells, that tenth must be in here. There you go. Which now means for 2 tenths to be in here, that must be a tenth. For 2 tenths to be in here, that must be a tenth. The last tenth can't be in those cells because they will be next to trees. They will be next to other tenths. So the tenth in this cell must be here. We can also place the digits here because we know 2 and 3 have to be the tenth numbers. This must now be 4 to make 6 as your total. This could be 1 or 2. I don't think we know. Well, we can finish this box. This has to be 1. That has to be 4. This has to be 2, 4. This has to be 3. That has to be 1. I think that's all we have. Right. So, yeah, this is a tree, that's a tree. But we know this tree has to be connected to this one because it can't be connected to any other tenth. So we can draw a line here actually. Let's draw a line to connect those. And then this one also has to connect to a tenth, can only connect to this one. Right, and we know ones are not trees. So 1 has to be here, meaning that's 2, that's 1. And I think we can finish the puzzle at this point so by regular Sudoku. So let's draw the final, let's color in the final things first. So those digits would be, whoa, what am I doing? Those digits would be trees, which are green, which must be connected to their respective tenths, which we have. And that last digit there is a 2. Nice. Okay, well, that's a very interesting rule set. There are a few tricks I found in this puzzle that is only applicable for 4x4s. So we might have to figure out new ways to figure out stuff in the 9x9. But I have that right here. The rules are functionally similar, except that, okay, you can see the whole grid. Good. Except that trees are now the digit 9. Yeah, everything else is still identical except the trees are now digit 9 and not 1 anymore, which I have to remember. So let's begin solving this one. Let's start with the most obvious one. That's a 4. And also the 2 and the 3 here. And the 4, in fact. If they're outside, what do they mean? Well, the tens must sum to 2, 3, or 4 here. But what that then means is that there can only be one tent, which is 2 itself. That's because 2 in 2 cells isn't possible. 2 in anything more than 2 cells is also not possible. Yeah, and therefore the tent must be a single digit 2. For the 3, it's basically the same. It could technically be 1 and 2 if you use 2 cells, but because... Oh, it could be 1 and 2, right? Because 1 is not a tree, that's it. Right, so there could be multiple tents in the 3 and the 4, because they could be made of 1, 2, and 1, 3 respectively. But the 2 here must be a single digit 2. Could probably do more stuff with the cages. Like those have to sum to 5, but can't include a 4. They have to therefore be 2 and 3. Those digits have an 8 in them, so they must include a digit 1. And I want to say... Well, what can I say? The 3... see, that's the issue. 3 could just be a singular tent with a 3 in it. Right? It doesn't have to be made of 1 and 2 in tents. Because if it did, then I could just say none of those are 1s, because those can't be tents. But no, you could have 3 as a tent itself. Same for the 4s here. 4s could also be 4 itself as a tent. Yeah, okay. Digit 9s are trees. And trees need to pair with a tent. I mean, what about the other low digits? They do have a lot of other things though. What about the high digits? Right, 14 might be useful. Because 14 could be 3 digits large, right? Yeah, you could make 14 as a sum of 3 digits. In fact, here you could have those 3 digits and one of those digits all be 10s and those sum to 14. Do they have to? No, you could also have 6, 8 as your 10s. Right. You could have 6 and 8 as your 10s in here. Or you could have 3 digits sum to 14. That's also possible. You can't have 4 digits in here because you can't fit 4 10s in those cells. Wow, okay. How do I start? Doesn't say anything about how many 10s are in each row, each column, or each box. We do know lake cells are not 10s though. Hmm. 14 and 3 digits, what would they have to be? I mean, they could be a lot of things, I think. Yeah, 3, 4, 7, 2, 5, 7. Yeah, they could be a lot of things, okay. Should I color things that are neither tree nor... Now let's do that. Let's color cells that we know are neither tree nor tent. Well, we know that is not tree. Because if it's 10, sorry, it can't be 10. Because if it was 10, it would have to be 2. So that's not 10. It's either tree or nothing. Oh, wait, hold on. We can do some bigger size logic with this. Because remember when I said for the 4x4, each 1 counts as a tree which must have a tent. We can do the same for this. Each 9 is a tree and each tree must have a tent. Therefore, how many tents can there be? There has to be 9. Has to be 9 trees and 9 tents. Okay, honestly, I hate using that word now because trees and tents just sounds like 3 and 10. This is so stupid. But yeah, okay. That does seem kind of cool. And therefore we know that every row and every column has one tree each. Which is not necessarily true of the tens, because tens can be any number. Trees have to be nines though. So yeah, every box, every row, every column has to have one tree in them. That doesn't help me say what a tent is, but maybe that could help. Could it? I mean, I was gonna say... I don't know. Maybe we look at the maybe we look at this cage again. If this column was a 1 and a 2 as a tent, then those two digits can be a minimum of 3 and 4. Because those aren't tens, so they can't be 1 or 2. Oh, but that's 7, which means you could put 1 there and everything would still be fine, I think. Dang. Yeah. So that doesn't really help, I think. Maybe we can do bigger logic here then. With like every single, if we take every row or every column and we kind of add up how many tens they have. No, it's still a lot. Like this 2 we know is 1. This 8 could be 3, it could be 2, it could also be 1. This 7 is the same. The 4 we know is either 1 or 2. This 14 we know has to be 2 or 3. That's just not constrained enough for us to figure it out. Okay. Every row column box has a 9, which is a tree. Can I try that? That kind of feels like sandwich logic, where we figure out where the 1s and 9s are in the grid, and we do a bunch of coloring. It feels very similar here because we know 9s are trees, right? But there's very little for us to go off of. What about... Yeah, I don't really see it. I don't really see it. I feel like we start with this 14, but that also feels very not right. And then like the 3 and the 2, 3 and 4 should give me information, but I don't think it does. It doesn't look like it does. The 23 kh, that's huge. And oh, wait a minute, that's relatively small, right? Because in 6 digits, what is the minimum you can have? 1, 2, 3, 4, 5 and 6 are the minimum you can put in a cage because digits can't repeat. Therefore those digits sum to a minimum of 21 if you add 1 to 6 in total. Which means that for 23, they have to be relatively small. And in fact, well, we already know 9 isn't in the cage. Oh, we could do that here, couldn't we? The 25 is relatively large, but we know 9 isn't in here. That does help a lot more than the 23. 23 is on the small side for a 6 cage, which means that it would naturally steer away from 9s. But the 25 cage is actually really large for its size. So if you take the next smallest numbers, 8, 7, 6 and 5, what did those add up to? Those are the 26, exactly. So we have the digits in here. Let's talk about how this could be. Because we know 9s are not in lakes. They have to be 5, 6, 7, and 8 at maximum. And those sum to 26, right? It's 2 sets of 13, yes. So to make it 25, you have to decrease one of these numbers by 1. But which can it be? We know that numbers cannot repeat in a cage, therefore you can't decrease 8, 7, or 6 by 1, otherwise you'd have a repeated digit. Therefore you can only decrease 5 by 1, which gives you 4, 6, 7, and 8. So we now know those digits are 4, 6, 7, and 8, with that digit not being a 4. Now, how does that help? I'm sure it does something. Maybe it doesn't though. I don't think so. Okay, what about this one? See, this one gives us a lot more options, right? Because we have 1, 2, 3, 4, 5, and 6, which sound to 21. We need 23, which means we increase either 2 numbers by 1 or 1 number by 2. Which gives us a lot of options now, because we could either increase 6 and 5 by 1 to give us 6 and 7, or we could increase a number by 2. We could increase a 6 by 2, like that. I think those are the only 2 options, right? I don't exactly know. Let me just go quickly look it up. Yeah, there are only 2 options. Right, there are only 2 options. And our 2 options are 1, 2, 3, 4, 5, 8, or 1, 2, 3, 4, 5, 1, 2, 3, 4, 6, 7. Which you could probably figure out yourself, but is that useful? We then know that 1, 2, 3, and 4 are in this cage somewhere. That digit can't be a 4. Ooh, and those digits sum to 5. Wait a minute. Oh, never mind. No, I was like, is this a 1, 2, 3, 4 quadruple? It's not. Because those digits do not need to be 1, 2, 3, and 1, 2, 3, or 4. They could be the other digits. But we know that in the 5 cage, digits must be a maximum of 4. So those have to be 1, 2, 3, or 4. We know that. I want to say that helps with the 4 and the 14. But, you know, those digits, it will only help if those digits are 1, 3, or 4. Which they don't have to be. They could be 2 or the other digits, you know. Yeah. If it were like a 1 in there, then we can say that the 10th, there can only be 1 tenth in this row, which has to be a 4 itself. And if this was a 4, then the opposite is true. I mean, I guess we know that 4 is in one of those cells in this box, because 4 is in here. Does that really do anything? No. The 8 has to have 1 in them. Yeah, what does that do? What does that do? I was saying, okay, what are the options for 8 again? Just so I can figure it out. It's 1, 2, 5, and 1, 3, 4. I think those are the only options we have. And checking, yeah, those are the only options we have. You can't really see me checking right now, but I'm looking down this list over here. It's in the app itself. If you go to settings, it will show up. And you can turn it on, and usually I don't use it because you don't have to. But in this case, because the point of the puzzle is not the killer cages, I will allow myself to do it. So those are our 2 options for the cage. Both of them we know contain 1 in them, which isn't saying much. But if it were 1, 2, 5, then it's either 2 here or 1 here or both. which means that in this column we can only have 3 as a tenth. If it's 1, 3, 4, it's the opposite, where it's that 3 can't be the tenth here, so you must have 2 tenths, which are 1 and 2. But though that doesn't do anything. Wait, am I stupid? Yeah, okay, I'm stupid. This can't be 2. We know in this, oh my goodness, I've been staring at this for like ages. But in this row, the tenth has to be the one with 2 in it, because the tenths must add up to 2. This digit can't be a tenth because it's a lake. So it's just 3, it's not 2. That's so stupid. But there you go, 3 in the corner. Awesome. So now we know that... We know what? No idea, but we have more digits now. We know this can't be 2, but it could be 3 if this was 10th. Which means it could be 9. Yeah. Maybe the 14. Hold on, let me think about the 14. 3, 4. No, the 14 has a lot of options, yeah. Even if you did some random stuff with the cage, 14 has a lot of options for 3 cells. For 2 cells, we know that for 2 cells, we do know that it has to be 6 and 8, because 14 can only be made with 6, 8, or 5, 9. But you can't use 9 because 9s are trees. So 14s in 2 cells have to be... 14 in 3 cells has to be... in 2 cells has to be 6, 8. In 3 cells, we don't know. In 4 cells is possible, but we don't know either. For example, this column could have 4 trees in it. 4 tenths, sorry. This column could also have... Wait a minute. No, maximum is still 3. The maximum is still 3. Right, the maximum is still 3. Why? Because a column can only have 3 9s in the 3 columns around it. Right? So if there are only 3 9s here, and even if they all look into the middle column, even if there are trees, if there are tens were all in the middle column, then we know that every 9 here, even if they pointed in the middle column, would only give you a maximum of 3 tenths in the middle column. And those columns on the outsides, they do not matter because they cannot point into the middle column itself. Yeah, so at the very maximum, you can have 3 tenths in a row or column. That is useful. And in fact, in the edges, it's only 2, right? Yeah, in the edges, it's only 2. One from the 10th, one from the 9 in the row itself, and one from the 9 in the row next to it. Or below it in this case. We know this is 1. Yeah. But again, this doesn't really help us, I think. Yeah, it really doesn't. Wow. Oh, wait. No, I don't think I mean those they're adjacent, which means something. Yeah, it might mean something because adjacent rows and columns do work with each other. For example, these two rows are encompassed within these four rows, right? They're squished between two other rows, which means that these two rows can have a maximum of 4 tenths in them. I mean, they if you take it, this could have 1 tenth, this could have 2 tenths in it at minimum, which means that those two cells have to have at least 3 tenths in them. They also have to have at most 4 tenths in them because they can only be filled by, the 4 9s in these four rows. Oh, but what about this? Those two rows in 3 rows have to have at most 3 tenths. Oh, but it could be 2 if the 7 and the 8 were their own tenths in each row. Oh, well, they can't both be 3 then. Neither of them can be made of 3. Because if any of them were made of 3, then the other row would have nothing. And in fact, this 7 can't be made of 3 at all because it's only seeing 2. It's only, this row is only beside another row, which means that it at maximum can receive 2 tenths only, at which point the 8 would only receive 1 tenth itself. But that's possible, So the 7 either has its own tenth or has 2 tenths. That could synergize with this cage, maybe. I don't know. I don't think so. Well, we've seen that. And then the 3 here is basically the same, where it can only be a maximum of 2 tenths. I don't know though. I don't think so. I don't think that helps. No, that wouldn't really. Okay, well, this one is kind of tough. Like, I don't know how much time I spent on this, but oh my. This one's kind of a doozy. Let's maybe think about the boxes, right? Yeah, there you go. No, it's not necessarily, is it? No, I was like, can those two really be tenths? Yeah, and the answer is yes. Yes, they can both be tenths. You could have those two be tenths and then those two be trees. Yeah, that's fine. I'm rereading the rules to see if I missed anything, but I don't think so. I was like, let's look at this one. I was like, maybe that's useful. It's not useful because you could have 2 tenths here. That's entirely fine. If you can't, then I can say that this has to be 2. This has to be 2 tenths making up 14. But no, you could still have 2 tenths here. Therefore, you could have tenths over here making 13. Wow. Let's see. No, I still don't see it. I still don't see it. Whatever it is I meant to see, I do not see it. Oh my. It's possible for, yeah, it's definitely possible for a row, a column, or a box to have no tent in them. They must have a tree, but they cannot have a tent. They do not necessarily need to have a tent. They could, definitely, but it doesn't have to be the case. Oh, I really want to say it's this 8 cage with the 3 and the 4, but I don't think I can. I don't think I can. I don't. Sorry, was doing something. If it were... Right, okay, so maybe this 13 and this 3 and this 14 cage then. Because if it were two tents, it definitely could not be those two, because 2 tents has to be 6, 8. And this can't be 6 or 8 because, you know, the 3 here means that this definitely can't be, you know, more than 3 if it was a tent. Therefore, if it was 2 tents, one of them has to be here. If it was 3 tents, then those 2 are tents with one of them being here. So that definitely has a tent in there somewhere. So finally putting something else in the grid for once. Don't know where the tree for this tent would be. It could be beside itself. It could be above or below it. But that does mean that none of those are tents. Which helps what? The 4 clue maybe? We know that's not tent. Yeah, I think that's not tent either. Yes, because those digits have to have a 4 in it, so if this was a tent, it would not be 4, but because this is only 1 digit, you either have a 1 here or a 3 here. You can't have both be outside. So this digit also could not be a 1, could not be a part of a 1-3 pair because it could not be 1 or 3. No, it could. What am I saying? It could. You could have something that goes a little like 1 here, 3 here, and then 1 here. That's fine. So this could be tent. Okay. Well, yeah, okay. That also could be tent if the tent was here. Oh, we know that's not tent though, because we know there has to be at least 1 tent here. We know those, yeah, we know there are 2 tents. If there is a tent here, there is at least 1 tent here. There is either 1 or 2. So that cannot be tent, because if it was, it would break all of those. It would make those all non-tents, which is impossible. Right, well, because they must have a tent in them somewhere, could that be a tent in one of those cells? There can't be a tent in both cells, we know that. But could that be a tent in one of those cells? Or yeah, yes. But okay, let's think about it. I need to think about it really hard. Could that be a tent? If it was, then none of those are tents. Meaning the 4 here has to have a tent in one of those cells. And you cannot have 2 tents because they can't touch each other. So that 1 tent has to be 4, which isn't possible because none of those are 4. So that means this isn't tent. Okay. Yeah, none of those are 4s. So if none of these are tents, that doesn't work. There has to be at least 1 tent here. If none of those are tents, you need a 4 in one of those cells, which just isn't possible. So one of those are tents, meaning that none of those are tents. Cool. They could be tree though. That's why I leave them half shaded. They could be tree. Oh, I get it. One of those are also tent. Because those, well, no, you could have 1 tent here, right? I was like, could you have? You definitely can't have both of those be tents because those are both, because then those would both be non-tent, which breaks this 14 kg. You wouldn't have enough tents to make 14. So those can't be both tents, but it could just be a singular one. They could be a singular 4. So yeah, it is possible to just be 1 tent here, and I think there must, because there can't be no tents here. So we know there has to be 1 tent in one of those cells. There can't be 2, there can't be 0, there has to just be 1. Okay. Then we know it has to be... therefore we know that those are both... Yes, we know now that those cannot both be tents. If they were both tents, then both of those would be non-tents, which then we know fails. So there has to be 1 tent here, therefore there cannot be 2 tents here, there can't be 0 either, therefore there has to be exactly 1. Awesome, that also means this is not a tent, because there's at least 1 tent there. Cool. Right, and can I therefore say, because there's 1 tent here and 1 tent here, there is also 1 tent here and 1 tent here? Yes, because you either have this or this. You can't have them touching each other like that, and you can't have both of them be tents in the same row. So it has to be either that or that, which means one of those are tents, which might affect the 3. Does it? Oh, there you go. This can't be tents. Got it. Alright. In this row, we know there are 2 tents. There we go. And 2 tents in 14 cannot be 5, 9. It has to be 6, 8 like we've discussed before. This cannot be tent because it will be part of the 3 column and would have to contain 6 and 8, which just doesn't work because the 3 tent, the 3 in this column implies the tents must add up to 3. So that cannot be tent. Wow. So that's tent, which means that is not, which means that is tent. Therefore, that is 6 or 8. Oh. Whoa. And then we can mark... Well, this one... Oh, that could be tree. I mean, one of those are trees. Well, we know those are all no longer tents. So let's mark that. Trees can touch each other diagonally. They obviously can't do it vertically because... They can't do it vertically because, you know, they're both 9s and then they can't see each other vertically. They could be diagonally though. So trees can touch diagonally. Although we know this one has to have a tree beside it, which has to be one of those cells. So one of those cells has to be a tree, which is a 9. Therefore, none of those cells are a 9. The tree for this tent has to be up here. Great, and that is a 9. Alright, another digit. Oh my gosh. Which means those have to connect. Cool. That also means that... I want to say none of those are trees, but honestly I can't really do that. I can't really find a good way to mark that. Yeah. Because anyhow I mark that, the colors will always be on the wrong side. I want the gray to be on the right side to indicate no tree, but it doesn't work here. No matter how you mark it. Yeah, the gray will always be on the right. Except here, in which the gray is on the left. Maybe I should do that. But I think it's a bit pointless. Well, what I do know is that now none of those and none of those are trees. In fact, none of those are trees, none of those are trees. We know none of those are trees either. I don't know. None of those are tents because we know tents in one of those cells. So none of those are tents. They could be tree. They could also be nothing. If we know it's nothing, could that be tent? No, that cannot be tent. Because if it was tent, then it must have a tree somewhere. It can't use this tree, and none of those can be nines. So that cannot be tent and is therefore completely nothing. I think same for this. Because this... Yeah, because wherever the 9 goes here would have to connect to this one. Therefore, this one cannot take a 9 here. It cannot take a 9 in those cells. So that just cannot be anything either. And clearly, if those are trees and none of those are trees, none of those are tents either. Because tents cannot be next to each other. So there you go. This also can't be tree or tent. So there you go. This could be tent. And in fact, if it was, it would be... it could still be 1, 3, 6 though. Could also be, you know, just a 2 or a 4. Yeah. Interesting. I guess we now know that cell is either 1, 2, or 3. It's either part of a 1, 2 pair or it's just 3 itself. Great. Oh, and therefore, because we know this isn't a 4, we then know that the tens in this row cannot be 4 itself, because this can't be 4. So it must be 2 tens that add up to 4, which have to be 1, 3. Oh, that's cool. Which means one of those are tens firstly, and we can just mark everything that isn't tent there. But also means that this can't be 2, because the other 10 would have to be 2 otherwise. So there you go. This could be 1 if that was 1, I guess. Could also be 3. If this is a 1, it requires a 2 as a tent somewhere else. Which could be that one. It could be. If you had a 9. Well, can that be tent? Can any of those be tent? No, because you can't have a 9 next to them. There you go. The 9 here means that none of those are 9s. Therefore, none of those... In fact, none of those can be tens, right? Because none of those can have a 9 next to them. All of those are not 9. So none of those are tens either, and they're not 3 because 9 is already in the box. So those are nothing. And this one, yeah, this can't be tent either for the exact same reason. Because it can't have a 9 next to it. So it's not tent. This one can't be either because this one, again, can't have a tent in, can't have a tree there, and it can't take this tree. So that's not tent. Okay. Cool, we've marked those as all nothing. This could be tent if this was another 9. And this also could be nothing because it doesn't say anything about tents in each box. Great. Now what? We do know there's a 9 in one of those cells. Does that help? The 9 has to be next to a tent. I don't know. The 9 has to be next to a tent. Yeah, I'm not entirely sure about that one. Okay. Could we say something similar about the 14s in the columns now? Because we did work with the 14 here. I mean, not really, because we had to use the 4 to help us. So the 14s in these columns may be a little bit different. Yeah, maybe. Oh, I guess we know none of those are 10s, but because of the 9 here, none of those are 3s either. So those are just completely nothing. That also isn't. It could be 10th though, if we wanted it to be. If, you know, you had a 3 here. This could be 10th. Yeah. Okay. Now we clearly know that that can't be 2, so that can't be a 10. So let's just mark that down. This could be a 10th. In fact, it does favor it being a 10th a lot, because if this was a 2, that would just be 8. And then those would be 10ths, you know. Or it could be 2. Yeah, that would be 2, so it has to be 8. Can't be 6, because you need another 2 to complete it. Which doesn't work, so that definitely could be 10th though. Which means that 10s don't have to be here. Could be there. So now that could still be a 2-3 pair if we wanted it to be. Could. Okay. Let's talk about... I don't know really. What do we look at? No idea. Maybe those cells? Because those have either a 1 or a 3 in them. Right. No, I'm just kidding. Yes, because this here forms a sort of 1-3 pair. This kind of 1 or 3 in it. Whoa. Yeah, there you go. This is not a 2-4 pair though, because 2 and 4 could be up there. Yeah, so we know this forms a kind of 1-3 pair where 1 is in one of those cells, 3 is in one of those cells. Which means that those can be 1 or 3. Same for those two, those form a kind of 6-8 pair. Which means that none of those cells can be 6 or 8. And we kind of saw the 23kh as having 2 options, right? Either 1, 2, 3, 4, 5, 8, or 1, 2, 3, 4, 6, 7. Which we know if it was the 5, 8 option, then 8 has to be here. If it was the 6, 7 option, then 6 has to be here. But as of now, we don't know yet. I mean, could this be 1? If it was, then we know that would be 1. Wait, why 1? No. What am I doing? Wait. This is not 1, 3. Oh no, it is 1, 3. What am I saying? It is 1, 3. No, it is. I was like, isn't it 1, 2? No, it's 1, 3. It's 1, 3. It's 1, 3 with 1, 3 here. Okay, I kind of tripped out myself there. This is 1, 3. This is 1 or 3. My goodness. If it's 3, it's alone. If it's 1, it needs a 2 somewhere. Oh, but we know none of those are. Oh, okay. If it's... We know that in those 2 cells there are exactly 2 tenths, because in these 3 cells there are 3 tenths, and this cell and this tenth are completely confined to that column, which means that to its right you can only ever have its own trees matching its own tenths in some way. You cannot have trees from this side matching with tenths from this side, for example, which means that there are 2 trees and 2 tenths in here which just have to match up. No, that's not true. You could have a tenth be there. I guess another thing you could then say is that there are 3 tenths in those cells. No, that could be 4. I just realized that could also be tent, giving us a fourth tent. Yeah, that could also be a tent. Sure. So there could be 4 tents in here. Dang it. Okay. Ooh, wait a minute. Wait a minute. How many tents are there here? Aren't there 4? There are 4 tents, and there are 4 trees in these 4 rows, which all have to match with a tent inside. Whoa, okay. So now what that means is that every tree here has a tent, and all tents are in here, which have to be part of the trees outside. Now there could definitely be tents more. There could be more tents on the outside rows. You could have tents from outside trees coming in a bit, but every tree here has to be from a tent in one of those 4 cells. Yes, and in fact, those trees, those tents, wherever that tent is, needs to have a tree from these 2 rows, because you cannot have a tree from up here. There's a 9 there. You cannot have a tree from down here because it cannot connect orthogonally to that tent. So wherever this is, the tree would be in one of those cells to match with it, which I guess we can mark, which therefore gives us a very weird X-wing. Yeah, I never kind of seen this kind of thing before. But that is a super weird X-wing which places 9 in one of those cells. I think therefore that means 9 has to be there. Right, because where does the tree for this tent lie? It has to be one of those cells, because it can't be next to itself, because we know trees have to be there and there, which basically mean none of those are trees. They can't take this tree either, because a tree here would have to connect to a tent above. So it definitely can't have a tree here. It can't have a tree up top, so it must have a tree at the bottom, meaning that it has to have a 9 in one of those cells. But because we know 9 is one of those cells, 9 can't be there. So 9 has to be here, I think. Which means this is completely just not anything. And these aren't anything either. Well, they could have tents from down here, that's fine. This one must connect to the tent up top, so we know now that that is just a tent. That is 1 of 3. Which is great, because what that means is that whatever this is can't be in here and has to be there. If this is a 1, 1 can't be here, 1 has to be there. If this is 3, same thing applies, 3 has to be there. So this is now 1 or 3. And those 2 digits are the same. Awesome. We also know that this can't be 10, that can't be 10, and they both can't be 9, so they're both all nothing. This could be 10, this could be 10. Well, could that be 10? It can't, right? If it was 10, it would need a 9 from one of those cells to match with it. But because of the 9s here and there, or rather the 9 here and there, those digits cannot be 9s. So this can't be 10 because it can't have a tree next to it. Cool. And I guess I'll mark this like so. Oh, we do have a 14 here though. And it does use that. Right, so this has to be 3. This has to be 3. Right. Yes, this has to be 3 tenths. Because it can't be 2. If it was 2, it would have to be 6, 8, which we discussed. And because this is 1 or 3, it can't be 2 tenths. Therefore, it's 3 tenths. Every tree from these 3 columns has to match inwards to this middle column. What does that mean? I don't know exactly. I wonder if I should do anything more interesting. Or rather a bit more tedious. Like if this was a 1, could we figure out what the triple was? If it was a 1, then our triples would be 1 plus 13, which is either 167 or 158. If it's a 3, then our triples would have to add to 11, which have to be either... It can't be 9, so it can't be 329, it can't be 338, it has to be 347 or 356. Okay, that doesn't do anything. Yeah, those are 4 different options, but we can't really tell you which one. So no. Yeah, I definitely should have another color for not tree, I guess. We could have another color for not tree. Like, we could have yellow for not tree. So those are not tree. And I'll mark it half shaded just so it's easier to tell. Those are all not tree, you know. Those are not tree, those are not tree. Which I'll mark like this. Those are not trees. And then these grey ones are not tents, which could have trees in them. And then the yellow is not trees but could have tents in them. Okay. I mean, we therefore know that one of those have to be trees, and then one of those has to be trees. I mean, this one could have a tree anywhere, honestly, so don't know entirely. Oh, wait a minute. Okay, we figured out the 14 in this column has to be made of 3 different tents. This cannot be tent because because if it was tent, where would the tree go? The tree can't be there, or there. So this can't be tent. It has to be absolutely nothing. Awesome. Now, therefore, there must be 1 tent here and 1 tent here. You can't have 2 tents in either of those, and you can't have 0 tents in either of those. So they have to be 1 tent each. If this was a tent, we know the tree has to be there, and if this was a tent, we know the tree has to be here. If that was a tent, the tree could be anywhere. Same for that. Wait a minute. Again, we know all trees in these 3 columns connects inwards. If that was a tree, it would have to connect inwards. Therefore, if there were any tents here, that wouldn't work because no trees could match there. But if that was not tree, right? If that was something else, like nothing or a tent, that would work, wouldn't it? Then you could have a tree in here connecting out here, you could have a tree in here connecting outwards, and then that'd be nothing. Yeah, okay. No, I don't think I see. I don't think I see it. Have we figured out this one? If it's 1, 3, 4, can it be 1, 3, 4? Then this can't be both 1 and 3, because then you'd have 3 digits be 1 and 3, which is impossible, which means... no, it's fine, it's fine. Yeah, this could be 1, 3, 4. It could also be 1, 2, 5. Wherein those digits can't be both 1 and 2. Well, they could. They could be both 1 and 2. If you had 3 on the outside. I don't know. I don't know. Yeah, okay. This 14, I think this 14 must have two tens. Right, and the reason why is because these two 14 columns take up 5 columns total now, and therefore can only have 5 trees providing tents for them. And therefore, if this takes 3, this can only take 2. So they must take 2 tents only. What does that mean? Oh, that can't be tent either. Hold on. That can't be tent. And that can't be tent. None of those are tent. Why? Because if they were tent, they would need a tree next to it to connect to it. But we know a tree in any of those columns have to connect to the middle. But right now it's not. Right now it's connecting downwards. So that can't be a tent, and by similar logic, that can't be a tent, which means those are both nothing either. Because we already know those are not trees. We might be able to do something very similar. No, if this was tent, it could be from a tree out here. Yeah, okay. We know that there are 2 tents here. Right, and if the 3 trees here are connecting inwards in this one, the 2 trees in those 2 cells have to be connecting inwards here. So this one is its own system, where it already has 1 tree and 1 tent, although we don't know where, we know it does. The remaining cells here, and I guess that, have to be its own other system. Yeah. Yes, and because we know there are 3 tents here and 2 tents here, that's all 5 tents from these trees. I think we can therefore safely say that this can't be tent. Because if it was, then you could only ever have 1 tent in here. Because whatever tree is in here can only provide a tent for this column, and cannot push a tent into that column. Yeah, so this cannot be tent. There you go. This has to be tent, I'm pretty sure. Which has to be 6 or 8. The 9 definitely can't be there, because we know one of those cells are 9. That is also not 9. But we know that's not tent either. In fact, we know none of those are tent. In fact, that is just nothing. None of those are tent. This can't be 9. I don't know why it's still there. Yeah, okay, there you go. There's a tent here and a tent here. So should I mark that down? Let's try marking it like that. 1 tent here, 1 tent here. We don't know where the tent is here. There could be a tent here if the 9 was down there somehow. There could also be a tent in any of those, so I think we can figure out a simple way to find that. Yes, okay. Now what? Not sure. Oh, looks like we are past the hour mark. Dang it. Already past the hour mark. Oh my gosh. Sorry, my brain is taking a while. I don't know if I should split this up into parts. I don't think I will. I don't think I will. one of those, I mean... Does that help? I mean, if this was a 10, that would have to be 2, right? If this is a 10, it doesn't have to be. In fact, it can't be 2. It doesn't have to be a 2. It could be anything else. Because it's no longer stuck in here. Oh, we know there must be a 10 in one of those cells, don't we? Right, and... Okay. Yes, we know that none of those... No, that could be 10 if it was 2. No, wait. No, it can't. Yes, it can't be. It can't be. Because if it was 2, then this digit and that digit would have to sum to at most 5, which means the last digit has to be at least 9, which doesn't work because there's already a 9 in there. It can't be 9 and it can't be greater than 9, so it can't be at least 9. So you can't have 2 as part of your 14. So that cannot be your tent. It is just nothing. Which means that is your other tent, which must be next to a tree. We know one of those are therefore a 9. We don't know exactly what that is, but we know that's at least 4, I think. It can't be 3, because 1, 3 here. Your last digit has to be 10, which doesn't work. So it is at least 4, which doesn't do much. But awesome. Okay. Now what? Well, we know that's 10, so none of those are 10s. Let's mark that down. Actually, we also know none of those are 10s. I guess we should have done that because we know one of those are 10s, which means none of those are 10s. Which probably would have helped, honestly. Which probably would have helped me make this initial deduction a lot faster. But we know one of those cells are a 2 then, because one of those cells are the 10th. And I'm just gonna mark it like that, so you can sort of tell here. I mean, these colors look a lot like candy corn, if I remember right. If this is 2, then this has to be... wherever the 2 is, right, I can say that if this is 2, the tree has to be here. If this is a 2, the tree can't be there, the tree has to be here. So we know one of those cells is the 9 where the tree is, which means that cell is not a 9. That cell is the 9, which is the tree. Which means, well, that connects over to there. That cell cannot be a 9 or a 10th anymore, so it is just nothing. That is, well, that's not a tree, but it could be a 10th, I believe. No, it can't, because if it was a 10th, where would this tree be? It can't be there. So this can't be anything. And in fact, this can't be anything either. It can't be tree, it can't be 10th. If it was 10th, it would have nothing to connect to, so it's just nothing. Which means that our last 10th is somewhere in here. Where would it be? It could be there, right? If you had a 6-8 pair like so. And you have your 9s here and there. Yeah, that's fine. Oh, right. So... Right, this 9 cannot connect to this one. Because we know that all the 9s in these 3 columns connect inwards. I keep coming to that fact, and that's actually so helpful. Right, so that can't be a 9. Because it has to connect inwards. Sweet. So that's nothing. That's just not 9. Which means that 9 in this column has to be here, giving us another tree. Which does connect inward, because we know that it has to. So that can't be anything now. That is just 10th. That is nothing. And then we know those are not 9 and those are not 10, so those are nothing either. Which means we now know that 9 has to be here, which has to be next to 2. So there's everything. That must be 10th. That must be tree. And those two do connect to each other. Therefore, we know this must now be 8. Because if it was 6, you need another 2 in the column to make 10, which doesn't work. So that's 8, that's 6. Ooh, more digits. Sweet. I guess we now know 6 is one of those cells by regular Sudoku, which we haven't done in a while. We might get back to regular Sudoku when we're done, but... Okay, 9 here means none of those cells are 9. None of those cells are trees, therefore. Trees are one of those cells. Same there, and I think one of those are 9s, right? Yeah, because of the 9s here and here, none of those are 9s. 9's one of those cells. If this is a 9, we know that the tent it's next to can only be here. If this is a 9, the tent has to be here or there, which means that this can never be tent. So that's nothing. Yeah, so we know now that one of those has to be the tent, which has to be an 8 to make 14. Although I don't know which. Yeah, although I don't know which. Okay, how many is that? This one still needs a tent. I think we figured out the rest of the tents already. We know there's a tent in here. Should I mark that? Let's just do that. There you go. One of those are tents. Actually, therefore, those are not tents, which we already know. Actually, yeah, we already knew that those are all not tents either, because there were already 4 tents in here, which all added up to 4 and 14 respectively. So there would have been no more tents. Yeah, I think that would have made it a lot clearer. Right, so though that is the only tree with a tent we still haven't figured out yet exactly. Right, there you go. This 2 and this 8 means none of those are tents, and none of those are trees either, so that's just all nothing. Okay. I mean, we haven't really looked into the 8 and the 7 yet, but hopefully those are maybe just normal stuff. I don't know. We also know that this 9 connects to that, and this 9 connects to one of those. So whatever the 9 is, those are the only things it can connect to. Therefore, none of those are trees or tents. They are all nothing. That could be tent, I think. Well, could it? No. It has nothing to connect to. In fact, none of these have anything to connect to. This one either. This one also has nothing to connect to. We can't connect to that. So all of those are also nothing. Great. What now? This one? See, I still don't understand how to resolve this. If its tent is in here, we know it's a 1-2 pair forming with that. But if the tent is here, then this is just a regular 3 here, which seems to work, right? Yeah. One of those cells are 8. I guess we can mark that down. Actually, we know that isn't tree, so we can mark that as just this. No need the yellow anymore. Yeah. Okay, wherever the tent is here, we can figure out where the tree goes, right? Yes, if the tent was here, the tree has to be above it. Same for that. If the tent was here, the tree has to be next to it. Same for that. So wherever the tent is here, we can figure out where the tree goes, which would allow us to disambiguate everything else here, which could make this quite useful. No idea though. Again, haven't used this 7 clue yet. How do we use it? Well, we know there's 1 tent here, there's 1 tent here, and one of those are tents. If it was anywhere else, if it was in one of those cells, then you would only have 2 tents here. 1 here and 1 here. No, I think it still could be anything. Whoopsies. What could that be? That could be anything up to 7, right? It's anything from 1 to 7. If it's 7, it's itself. If it's anything else, it forms a pair with another tent in its row. Does that help this? I mean, maybe it does. I don't know. Shall we mark the things we haven't used this clue, we haven't used the 3 clue, we haven't used the 8 clue and the 7 clue to completion yet. The rest we have. The 14 clue we actually haven't, but we know the 8's in one of those cells anyway. So technically the 8 clue, the 14 we've used. Technically. I mean, if the tent was in one of those cells, and we know this can't be the 8 tent, right? Because that plus that would give you something more than 8 already. But otherwise, if this was empty, then this could just be 8. And in fact, if this was empty, this is... If this is tent now, then this just can't be 7, but it will form a pair with those 2 cells. And then that will be 8. So it's either 8 here or 7 here, I think. Or it could be both. Yeah, it could definitely be both. In fact, it could be 8 here, 7 here, and then 8 here again. I mean, 8 is in one of those cells, I guess. I mean, we don't know if the 8 is in the tent or not. And I'm pretty sure it's not, even though it definitely could be. Oh, which means I'm not sure if it's not at all. It definitely could be. Dang, I don't know how close we are to solving this. I mean, I hope we're kinda close. But honestly, can't really tell. Can we resolve this in any way? I don't think so. Yeah, I definitely don't think so. No, we have to do other stuff first, right? It's a combination of the 3, the 8 and the 7 somehow. Because if one of those are tent, then we know it has to be a 2. Because this would have to be 1, that would have to be a 2 here somewhere. If it was 2 here, it would need another one. It would need a 6. Oh, so can this be tent? If it was tent, we know it's 2. But then it needs a 6 as another 10 somewhere, which doesn't work, because that digit can't be 6, that digit can't be tent. Whoa, okay, so this just can't be 10 then. And then if this was 10, it would have to be 2, that would have to be 5, which I think is fine. 5, 3, 6 works maybe. But we know that can't be 10. And if this is 10. Oh, we know there's 1 tent here. Oh, wait a minute. We know there's 1 tent here. If that is tent, it just has to be 8. Yes, because it can't be anything else. So if that's 10, it's just 8. If that's tent, then this can't be tent, because you can't have 2 tents with an 8 in one of them. The other one would have to be like a 0. So it's either this is a tent and this is not, or the other way around. Which means there is always just 1 tent here. But I don't know if there's a tent here or not. It could be either. It could be... If there is a tent here, then that's the 8. If there is no tent here, then that's the 8. Dang, okay. If this is 10th, then those two add to 7, that's fine. If this is 10th, then those two add to 7, that's also fine, because this would have to be 2. This could be 5 with 3 and 6, or 5 with 1 and 8. Yeah, there's so many options. And this one, if this one is 10th, then none of those are 10th, and then this would just be 7, which could mean anything. And then this would be 8. Yeah. Do we do the 14? Do we do this 14 specifically? This 14. With a 3. If it's again, didn't we have like a bunch of options? We had a bunch of options, didn't we? Should we write them down again? If it's 1, it has to be with 6, 7, or 5, 8. Can we figure out which is wrong here? I don't know, but if it was 3, it would have to be 3 with 4, 7, or 5, 6, right? So those are our options. Which kind of means that this is actually pretty high. It has to be at least 4, and it can't really be as high as 8 because, you know, that digit can't be higher than 7. So it has to be at least 4, and it has to be at most 7. But we know that one of those cells are 4 because in this case there must be a 4 and that isn't. So one of those cells are 4, which means this isn't 4. 3, 4, 7 is still possible if this was 7 here. And if this was 4, which I think is also possible for that to be 4. I mean, but this one is the one that's not 1 or 3. Right? Yeah, so this one, isn't this one also... Well, this one could be anything from 4 to 8 now, couldn't it? Yeah, this could be anything from 4 to 8, so... That's a lot less of a good thing I can say. I think it might be time to look at this 8 cage again. Because the 8 cage also has 2 options, which are either 134 or 125. Can we eliminate any of them? No, I don't think so. So what? What? What am I doing? What am I doing here? This is a huge roadblock. Like, I actually cannot see what I do. Oh, do we know that 8's in one of those cells? We do. Yeah, so in this box, 8 has to be here. That forms a 6-8 pair. So those digits are 1, 5, and 7. Now what? I always ask that. It's so dumb. I mean, the puzzle's not dumb. It's just I'm not seeing things. I'm not seeing things. 8 in one of those cells. Stairs. There. So I guess 8 is in one of those cells now, ignoring the pencil marks we placed there. And then how do these digits affect the 21? The 23, sorry. It's either 8 is in one of those cells or 6 in one of those cells. It's not both. It's not neither. Oh no, and then this 5 cage we haven't talked about, but I don't see anything to do with it either. It's either 2, 3 or 1, 4. If it's 1, 4, it's a bit more interesting because now 4 is in one of those cells with one of those cells, and that is no longer 4, which eliminates 3, 4, 7 entirely. But again, it could still be that, I think. Uh, this one, I don't know what I'm looking at. If this is 2, that's 5. If this is 10, it's 2. That's 5. And this would be 1. That would be 1. And then this would be 1. But if this was like a if this was an SL, it could be, you know, 2 or 1. 2 here and then 1 1 here and then 1 here and then 3 there. And if this one was a 10, it's just 8. Because why? Wait, why? Couldn't those both be 10? I thought they could. I think they could. Yeah, those could both be 10 as well. No, because if those were both, yeah, alright. If those were both 10, that doesn't work because this would have to be 8. Because the 10th in one of those cells has to be 8. So they can't both be 10. Therefore, there can only be one 10th in here. It's either 8 here or 8 here. Which means what? Could this now be a singular? It still could, right? Yeah, it could be 8 here, 7 here, and then 8 in one of those cells. Yeah, that will make 9. Yes, that would make 9. Okay, honestly, wait, which clue? What am I not seeing? Oh my goodness, what am I not seeing? This is if this is 1, 3, 4. Hold on a minute, hold on. If that's mine, that has to be 2, right? 2, 1, 1, 3, 4. Alright, okay. Sure. If that is tent, what would it be? If that's tent, you could have 1 here and 1 there. If it's a tent and it's 2, I mean 2 could still be one of those cells. 2 here would make this a 1, 5. When 2 here would make this, I think, I don't know, it could be anything again. Well, no, a 2 here would make this a 1, 3, 4. Yeah. Wow, gosh, if this is 1, 3, 4, these can't be both 1 and 3, so there has to be a 4 in one of those cells. And then those two cells will be the same. If this is 1, 2, 5, it really doesn't matter why anything goes, because it could just be 3 to evade everything. Hold on. Hold on. I'm starting to see how all 4 of these clues merge together in some funny way. That one is also involved somehow. So messy though. That's 3. If that's 3, or if that's 1, 3 here means that this is where the tent goes. Tent over there with tent here could mean anything. It also could mean that is a tent and that is the tent itself. And then 1 could be with 7, 6, or with 6, 7 with 5, 8. Bro, I don't know. Bro, I don't even know at this point. I mean, if 8 was here, that could be 8, right? Dang. Dang. 9 here means that's 10, but 9 here means either of those are 10. We know 8 is in one of those cells. Actually, if 8 was there, we know that's 10. If 8 is there, we know that's 10. If 8 is in one of those cells, then it's immediately not a tent because it can't be part of a tent. But that also means that that can't be 8. Huh, so I don't think that's 8. Because we know if 8 is in one of those cells. If... No, sorry. No, this could be 8 if 8 was in one of those cells. Yeah, I don't know what I'm thinking. Yeah, if 8 was here, we know it's not there, but if 8 was here, that could and would be an 8. If 8 was here, 8 would have to be there, which puts 8 in one of those cells. If 8 was not in the way at all, you could have an 8 anywhere here, and then anywhere in here, I think. Oh, what the? This is getting really messy. I don't really know anymore. Let's just do the stupid thing and mark those. My gosh, this is actually kind of insane how long I've been staring at this. I'm not even close. It's not like you know that counting thermals one. It's like, what? I mean, okay, I've seen people spend hours and hours on puzzles, and I think I'm gonna do the same on this one. But honestly, holy moly. Where else do I look besides just focusing on these clues? And that maybe. I don't know, that doesn't really help. Do I have to bifurcate? Do I really have to? Oh, wait a minute. This can't be a 2-3 pair. Because if it was, where do 2 and 3 go in this box? They would have to both be in that cell. What? Okay. That can't be a 2-3 pair. Because you can't put 2 and 3 in the same cell. Okay, so this is a 1-4 pair. Dang, so now that can't be 4, which means that 3, 4, 7 really isn't an option, but that doesn't help. We know those are not 1 and 4, I guess. Whoa. So 4 is in one of those cells, 1 is in one of those cells. I mean, at least we have that. So where does 1 go in this box? It has to go here. Okay. So 1 isn't there anymore. And in fact, can 1 be here? No, because if 1 was here, then where does 1 go in here? If 1 was here, we know those digits are the same. So if that was 1, these are both 3s. Therefore, none of those digits can be 1. So this can't be 1. 1 must be here. Which means that's 3, that's 3, that's 1. Oh my goodness, we are breaking in somehow. Oh, jeez. Okay, that was something. 3 here means we are now missing those. This has to therefore be 3, 5, 6. Okay. 3, 6, 7. This 1 means that none of those are 1. 1 is therefore here, which has to be next to something. We don't know what that something is yet. But I can say that there has to be a tent here, otherwise you can never get to 7. Therefore that's not a tent. We do know it still could be 9, but that is definitely not a tent. Great, which means that the tent here, that must be our tent, which is just 8. So those are all not 10. In fact, the tree for this one must be here, so that's 9. Which means those are all just nothing. Which means that's 9. Okay, which means that's 9, which means that's 9. Which gives us the rest of everything. So now those are nothing. That is a tree. And I guess we can just kind of draw lines to fix everything up. This is now tree. There you go. Therefore, this has to be 1 or 2 to make 7, 5, 6. It can't be 1. It has to be 2, which must make it to 5. That is 6. Couple 6 9s here. Very nice. This can't be 8. So I guess 8 must be one of those cells as well. Alright, so this can't be 2, 5, it's 3 or 4. So let's erase that and erase that because those aren't part of the puzzle. Those aren't part of my solution. Okay, there you go. Jeez. Now here we still have a couple options. This could still be 2, 4, 5, 8 or 2, 4, 6, 7. What are those cells? Those cells are 2, 3, and 4, I think. None of those can be 3, so 3 goes there. It's a 2, 4 pair. 3 is in one of those cells, which means 3 is in one of those cells by Sudoku. 2 is also one of those cells, which forms a 2, 3 pair. So none of those cells are 2, which means this is a 2, 4 pair. Awesome. So now those cells are either 5, 8 or 6, 7. This can't be 6 or 8, so 6 or 8 must be here. Then up there would be 5 or 7. And then those are 2, 4, 5, 7. We know that's not 2 or 4 by the column, so that forms a 5, 7 pair. This can't be 5 or 7 anymore. That forms a 2 or a 4. Cool. This actually also forms a 2, 4 pair, which might mean something. I don't know. Six in this column, right? We know there's a 6, 8 pair here, so those 6s see those cells. Those can't be 6. 6 goes up here. What else do we got? 6 in one of those cells, one of those cells. Yeah, 6s do have quite some variety, I guess. 6 here means that can be 6. 6 is in one of those cells, which means 6 is now one of those cells. This digit is... Actually, this digit is that digit, because this is a 4, 6, 7, 8, so that is also 6 or 7. Yeah. That could still be 5, 6, 7, or 8 though. So we still got lots of options. Oh, although I guess, where does 8 go? It has to be one of those cells, which forms a 6, 8 pair. Which does mean that has to be 7, that has to be 5, which has to be next to an 8 to make 23. That is now a 6. Awesome. Those are 1, 5, and 7. Sorry, no. 5, 6, and 7. What am I doing? 5, 6, 7. Okay. We now know that that has to be 7 because we said those cells are the same. There you go. That digit is just a 7, which means what? I don't know. 7 is in one of those cells. And then we now know 7 is one of those cells, so that is not 7. Which means 7 in this box has to be here. I guess a 5 would have resolved that as well. We need an 8 in one of those cells, so that's cool. We don't know where that 8 would be though. This forms a pair. What is it? 5, 8. 5, 8 pair. Awesome. Right, and now 1 in this box is here, which resolves this for 1, 4 pair over here. None of those cells are 1, so 1 goes up there. We should be able to figure out, yeah, 1 is in one of those, no, none of those cells, oh wait, none of those cells are 6, which means 6 is over here. Oh, okay, so this is a pair, it's a 1, 8 pair. Yeah, and one of those cells are 1s, which does correlate with wherever the 1 goes there. What about here? What do we not have yet? A 5. We don't have a 5. It could be anywhere there though, so no. Oh, I see. Right, so I don't know if this is intended, I don't know if this is Sudoku, but whatever that digit is has to be here. Because in this column we don't have a 3 or a 4 yet, so if this is 3, it can't be in those cells, it would have to be here. If it's 4, it can't be in those cells, it would have to be here. So essentially those digits are the same, that's 3 or 4, forming a 3-4 pair here, which means that is not 4. 2 here, 4 there, 2, 4, 2, which does something, I don't know, that's a 5 though. Ta-da! I mean, I guess we could have just used a triple here to figure that out. This is 3, 7, 3, 4, 7. That is not 4. Actually, that's a pair. In fact, we know that now that is not 7, so 7 goes here. Those digits are 6 and 8, which we can resolve. Cool. Those digits are 3, 4, and 5. This can't be 3 or 5, so that's 4. That's 3, that's 5. Resolves is 3, 4 pair. That isn't fixed. Neither is that. That is not 3 though. Actually, it's not 4 either, so that's just 7. So that's just 3. So that's just 4. That is not 3. 3 goes there. Okay, I think we're right. We're doing regular Sudoku now, I hope. This is 5, 8. Yeah, this 4 resolves this 8 over here. I guess we can do that first. Which does allow us to resolve this 5, 8. That's 5, that's... Oh, whoa, 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 whoa. Hold on. I messed up. Somewhere. Crap, I messed up somewhere. Where didst thou screw up? Where did I screw up? Is this not right? Did I do this part wrong? Did I do this 3, 4 part wrong? Or did I do something wrong even before that? This is 3, 4, 7. This 3, 4 means that is 7. That's 3, that's 4. I'll do this as per normal, that's 2. 4, 2, 4, 2. 7, no, this is 3, 4, 5. This can't be 5, this is 3, 4. Uh-oh! Something's wrong. This is 8, but now that digit has no option. This is 2 or 7. Yeah, that digit has no option. Okay, everything else looks right so far, so I'm just assuming I got something wrong at the very beginning. Oh no. Alright, hold on. Let me just turn on conflict checker to see if I get anything wrong. Actually no, I mean conflict checker would have worked. But now this can't be 2 or 7. Crap. No, I'm pretty sure I did everything right though. Starting with this pair over here, which had to be 1, 4, because it can't be 2, 3, otherwise you'd have nothing to go there. Because that can't be as low as a 2 or a 3. Okay, I probably just did some Sudoku incorrectly. How far back do I have to go? Crap, I don't know how far back I have to go, man. Is this not a 6-8 pair? I mean, it is, right? No! Why did I say 6 is one of those cells? Why did I say that? It's not. 6 could be there. Wait, no, because... Right, I was saying that 6 is one of those cells, which means not there. That's not true. 6 could be there. Oh my god. So this is not... 6 is not one of those cells. What am I doing? 8 isn't one of those cells. Okay, well, apologies, but... That was a huge mess up. Okay, let's just do everything as per normal again. This is a 1, that's a 4, that's a 1. I can still say that with confidence. This digit has to be 5, 7, or 8. 6, 8 pair here means that's not 8, so 8 goes up top. Those digits have to be 2, 3, 5, no, sorry, 3, 4, 5, or 7. 4 can't be in those digits, so 4 must go there. 3 can't be there, so 3 goes there. Now 3 can't be there, meaning 3 goes there. This digit is a 2 to complete the row. That digit is a 5 or a 7. Those digits are 5, 7, or 8. 5 means that digit can't be 5. This 2 resolves this 2, 4 pair, which resolves all the 2, 4 pairs. I gotta be like super careful with what I do now. This digit therefore can't be a 4. It's a 7 or an 8. Okay. Well, by very long erroneous bifurcation, I could have said this is a 6, but I gotta figure out some way to actually prove that without saying I tried and it didn't work, so I'm gonna say it's the other way around. That does not feel right, so that is not what I'm gonna do. 3 and 4. No, 3 and 4 I don't think is the problem. 6, 8, 6, 8, 6, 8, 6, 8. No. This could be 5, 6, 7, or 8. This is 5, 6, 7, 8 as well. Two in this column. Can't be in those cells, can't be there. So 2 goes here. Have we tried 1? No, 1 is in one of those cells, and also one of those cells, forming a very useless X-wing. And we have 6, 7, and 8, which means we're missing like another digit. I think it's a 5. We're missing a 5 somewhere in here. It's in one of those cells. I know that because 5 can't be here or there. Therefore, 5 is not in one of those cells, which also works. It's in one of those cells. It's in one of those cells. It's like in one of all those cells. 5 is in one of those cells, which means it's in one of those cells, which works. It works. It works. By it works, I mean anything works. Because I haven't seen how to resolve it yet. Oh, this 2 resolves this 2, 3 pair. Cool. Pretty useless, but pretty cool. I think we have all the 2s now. Yeah, we do. 3s. Missing a 3 here. Wait, we're missing 2 3s. Yeah, 3 is in one of those cells, which makes sense. It forms a very weird X-wing like that. Cool. And then, I don't know, 4s. 4s aren't as close. Yeah, 4s are still pretty far away. I guess we know 4s are one of those cells. Oh yeah, in fact, because none of those cells can be 3 and 4, that can't be 3 or 4. This does form a 3-4 pair. Alright. So that's 3 or 4. Which means those digits are 5, 6, and 7. Which doesn't really help, but alright. Eight in this column has to be here. It's also not there, I guess. 8 is in one of those cells, one of those cells, one of those cells. It's in one of those cells. It is in one of those cells, which forms a pretty accurate pattern. Yeah, no, this is all fine. I don't know. This is also 5, 6, or 7. Wait, is it just Sudoku? Really? Am I being absolutely destroyed by Sudoku right now? I think I am. God dang it, dude. What am I? What has gotten into me right now? Do we have all the ones? I know we have an 1x1 somewhere in here. Sorry, I'm rubbing my eyes. I can only see. Let me guess. How long is this recording? 2 hours. Yeah, we've been in here for 2 hours. Awesome. Those digits are the same, which stare into those cells. Have we done all the 9s we have? Yeah, 9s were the trees. They were done very easily. What is the missing thing here? It's a 4, right? Yeah, 4 could be anywhere there though. Oh, this is kind of annoying. What? 4 can't be there, I guess, because it is 4. But 4 could still be one of those cells. 8. Oh, those cells come to 13, don't they? And they can't be 6, 7 because this can't be 6 or 7. There you go. So this can't be 6 and 7. They have to be 5 and 8. Because if they were 6 and 7, then this would have nothing to be. Cool. So now that's 6 or 7. Okay. That's also 6 or 7. That definitely took a while. So now we know it is one of those cells, which means this forms a 1-8 pair. 5 is now therefore over here, which means that's not 5. This is a 7, therefore that's a 6. That is not 6. Sweet. I think this is 1, 6, or 7 to finish the column. Fives. Right, so 5 has been one of those cells. I mean, to be fair, it's one of those cells, I guess. That is not 5, therefore. And in fact, because of the 5-7 pair up there, we know that's just a 6. So that's not 6. Does it tell us where 6 actually goes? I don't think so. Nope, I don't think so. Yeah, it doesn't. Okay. What else have we... I mean, we've used everything at this point. I believe we've used everything at this point. Four, 5... Yeah, this is a 4, 5, 7 triple. Well, that is not 7. Then this could be anything still. This looks like a 3, 4, 5, 7 quadruple. I kind of like that the little black areas forms tiny shapes. Cute campgrounds, I think. Could make a story out of this, I think. I don't know. I'm just staring. Here, is anything useful? And 4 is in one of those cells. 6 is in one of those cells. 8 is in one of those cells. But that doesn't do anything. Yeah, what is this? I mean, obviously it's not a daily pattern because... I mean, I can't tell you it's a daily pattern because I don't know what it is. This is 4, 5, 6, 7. This is actually not 6. Sorry, what am I doing? It's 4, 5, or 7. This is not 5 either. Yeah, this is 1, 4, 6, 7. This is not 4. This is not 7. This is 1, 4, 5, 6, 7. This is like, I don't know, 1, 4, 5, 6. It's not 1, it's not 7, so it's 4, 5, or 6. Yeah, pencil marking didn't really help, did it? What am I looking at here? Six is one of those cells, right? Because it needs a 6 here, and we know none of those are 6, so 6 can't be there. That forms a 4, 5 pair. Okay, so that's not 4. That's for 1, 1, 6, 7 triple. But that ought to help somewhat, this 4, 5 pair. Does it? Maybe? I don't know why that 5 is over there. Yeah, this forms a 1, 6, 7 triple as well, so 4 must be there. That's 3, that's 4, that's 3. Those can't be 3 or 4. 5, 7 pair here. 6, 7 pair here means that's 5, which resolves everything over here. None of those are 7, so that's 8, 7, 5. That's 5, that's 7. Oh, okay. I mean, we're reaching the end, I think. So this is on 7, that's 4. This is a 6, that's a 7, so this is 8, that's 7, that's 6. 7 here means that's 5, that's 7, that's 4, that's 5. 6 means that's 1, that's 7. That's 8, that's 1, and finally that's 6, that's 8. And that is a 6, solving the puzzle in 118 minutes. Oh, this was super cool, but I think my brain was just dying a lot. Yeah. Well, I mean, I definitely enjoyed this puzzle as well. I hope you did enjoy this video too. I'll see you next time. Bye bye.